start talking more about how to really sketch the graphs of these polynomials and come up with our equations for polynomials. So let's go ahead and jump right in. Okay, so we want to know what the difference between the graphs of the function x squared times x minus 3 times x plus 1 and then 3x squared times x minus 3 times x plus 1. So if we go to our graphing calculator and we type these into y1 and y2, again, the only difference is this 3 at the beginning. If we look at these two graphs on our graphing calculator, we see that they have the same x-intercepts and the same general shape of the graph, but our maximum and minimum points are just a little bit more exaggerated with the equation that has the 3 in front. So if we go back to our notes, so the difference between these graphs is the max slash minimum values. Okay, so our next problem is Melvin wrote the equation for this graph as y equals a, x plus 3, x plus 1, and x minus 2 squared. And we can kind of see that, again, just sort of pointing out the reason for this squared is because of the bounce at positive 2. And so what if we did not have a graphing calculator, but you were told that the graph goes through 1/16? How could you use this information to find the exact value and find a? So what we're going to do is this point of 1/16, this is going to be our x and our y in our equation. And so then we take our equation here, but then replace it with x and y. So this is going to be 16 equals a times 1 plus 3 times 1 plus 1 times 1 plus 2 quantity squared. And so again, the 16 replaces the y, and then our 1 replaces each of our x's here, here, and here. And so now we just simplify and solve for a. So then the way that this will look is we have 16 equals a times 4 times 2 times, also I messed this up, this should be 1 minus 2. So then we get that this is negative 1 squared. And so then we can multiply this out. So this is a times 2 times 4 is 8. Negative 1 squared is 1. So then we get that 16 equals 8a. So then we divide by 8. So then 2 equals a. Now you want to write the actual equation. So then we go over here and write y equals 2 times x plus 1, or x plus 3, x plus 1, and then x minus 2 squared. So that is how we find our exact equation. And so I have these steps written out for you guys down here. So again, the first step is that we want to write the equation with the a and factors from the roots and intercepts. Then we use that point from the graph to plug into x and y, and then we solve for a, and then finally write our final equation. And so if you guys need to, you can pause and continue to write these steps in your notes. And so then for this example, again, the first thing that we want to do is write the equation with a and the factors from the roots and x-intercepts. So This is going back to what we learned in 8.1.2. So we have our x-intercept of -2, 1, or -2, 0, and then 2, 0. So then that gives us the equation of y equals a x plus 2 and then x minus 2. However, because of this bounce at -2, we want to then have x plus 2 squared, because again, that bounce means that we're going to have that squared for that factor. So that is our first step, is writing our equation with the x-intercepts and a. So then the second step is we want to use a point. So we can use this point right here. So that would be the point 0, 16. And so then we plug this in for our x and our y. So then this would be 16 equals a times 0 plus 2 squared, 0 minus 2. And then our third step is we solve for a. So then we have 16 equals a times 2 squared times -2. And so then this would be 16 equals a times 4 times -2. So then 16 equals a times -8. If we divide by -8, then we get that -2 equals a. And so then our final step is we write our equation. So then this would be y equals -2 times x plus 2 squared, x minus 2. Now, kind of looking at this makes sense, because if we look at our graph, we see that our end behaviors are down then up. So again, end behavior is, up then down. So that means that it's an odd degree, which our equation does have a degree of 3. And then it's a negative orientation because it ends down. And then our a value is -2. So that would give us that negative orientation. So then what our equation is makes sense with the graph that we have. Okay, so then our last example is now we don't have the graph, but we're given certain information. So we're given that it bounces off the x-axis at -1, 0. And so it bounces at -1, 0, and then it crosses at 4, 0, and then goes through the point -2, -18. So let's first take our information and write our equation with a. So we would have y equals a, then x plus 1, because that's our x-intercept, and then x minus 4. Now, again, because it bounces off the x-axis, that's going to be squared. And then because it crosses at 4, that's just going to have an exponent of 1. And so, again, this whole part is coming from the fact that it bounces at -1, and then that it crosses at 4, 0. So then we use our point of -2, -18 to then do -18 equals a times -2 plus 1 squared, -2 minus 4. And so then this would be -18 equals a times -1 squared times -6. So then -18 equals a times 1 times -6. So then -18 equals -6a. We divide by -6. We get that 3 equals a. And so again, we then need to write this equation. So y equals 3 times x plus 1 squared times x minus 4. And that is our answer. And so again, just to sort of highlight a couple things, the -2 we plugged in for x here and y here. Okay, so that is all for today. Hope you guys get out, enjoy some of the sunshine this week, and then I will talk to you all later. Have a good day.